Hi, this is David Odell with Odell Complete Concrete. Today we're going to be changing a gas line, something a little new and out of my ordinary, but I pretty much can do it all. And this is just one of those cases where I'm going to do something different. So here's the heater for the jacuzzi and pool, and you can see it runs from there and it runs past all this pool equipment, and then it ties into the meter. And that's how you get the gas to the heater, and that's how you're going to heat your pool. So there's a gas leak somewhere underground here. It was determined by the gas company, so they had to shut it off at the valve at the meter. They still had gas in the house, but no gas for the pool heater. I had to determine the best way to get from point A to point B, and I came up with this particular strategy. I went with a 1 foot trench through this concrete here around the area drain, and I was guessing from just experience and stuff that all those pipes from the pool equipment going back to the pool were going to be somewhere in this area, and I was definitely going to run into them. And there's about 6 of them, so that's quite a bit of space when you put 1.5 inch pipes side by side. So I knew there wasn't going to be much area going through this narrow corridor here between the block wall footing and the pool equipment pipe. So I had to find a spot, and what I did was when I went closest to the wall, and I knew the footing would probably pop out another foot, so we'll see if it works and if I found a good digging area to get this pipe 18 inches below grade, because of course we're going to get inspections on this through the city throughout this whole process, so we have to go by the book, and it's going to work out real nice. Here's the part I got to tie back into, and you can see they've got that pipe wrapped with some 10 mil poly tape, and that's basically a rust preventative, so the pipe doesn't rust out. It waterproofs the pipe. That's what that's there for. Now I'm going to saw cut this with my 12-inch steel cutoff saw, and I'm going to wet vac the slurry up at the same time to try to limit the mess, because if you don't get it right away, it's hard to get up later. I'm going to be removing this concrete at the same point, so I don't have time for it to wait and dry and all that. So I'll vac it up. I'll be able to pound this concrete out with the jackhammer without splattering slurry everywhere. So now we're going to break out the Makita 60 pounder, and we're going to pop this concrete out, and we're going to try not to chip the edges. And the secret to that is either you double cut it, everything, or you chip it into very small pieces. So what we're going to do is chip it into the small pieces so it just falls out of this little crevice without prying or wedging against the surrounding concrete and chipping it. Now this concrete's been in here as long as the house, about 25 years. It had rebar in it too, and I'm thinking that's probably why it's held up so well over the years. Wasn't a crack in any of this side yard concrete like what I normally run into when there is no reinforcement. Here's the pipe here, and what they've got here, that's steel pipe with epoxy coating on it, and that of course is just the end. There is a transition fitting. This is these epoxy fittings go for about 3 feet, and then they have a transition fitting that goes from the steel to the plastic poly pipe. That's the part below grade, and I'm guessing that compression fitting that they used on this for the transition fitting from steel to poly, that's probably where the gas leak was. So I'm not going to really waste a lot of time to figure out exactly where it was. I'm pretty confident that's where it was, but it was at the other end near the gas meter. So what I'll do is just dig a new 18-inch trench, and I'm going to drop poly pipe in as well. The only difference that I'm going to do on this one rather than what they did before is I'm going to weld the pipe together. I'm going to rent a machine that actually heats the fittings and it allows the fittings to actually weld together. We'll show a little bit of that too. And the fittings are a lot less expensive that way as well. Those compression fittings can get pretty expensive. If you only got a couple of them, it doesn't really matter. But for a lot of fittings, you're going to want to rent the heat treat gun to get these things hot and welded together. Let's see, what pipes did I run into as we went through. Yeah, I found all the pool equipment pipe, and they were, as I anticipated, side by side. And if I had broke one digging this out, it would have been very difficult to even get a coupling on them, since they were just sandwiched together. But I got lucky. We were able to dig under the drain pipe and a couple of sprinkler line pipes too we found in here. Kind of went around everything. The nice thing about the poly gas line, we can bend it around stuff a little bit here and there, and get it into these kind of tight situations where steel you're kind of locked in with straight runs, 45s and 90s, and a lot of times those don't work in these situations here. The poly pipe is not going to rust on you. It's you're not going to have any problems. The only problems you could have is on your fittings. And that's why we chose to go with the welded fitting. Now the thing about the plastic pipe we're using here, we're going to have to put a tracer wire on that pipe. And that wire is going to be popped up at both ends where the gas line is run. And what that allows to happen is if you were to call dig alert or something like that, or if you did want to locate exactly where that gas line is in the future before you were to dig, or if you want to do something to it, you could hook an instrument to either end of that wire, and you could walk along there. It'll tell you the exact depth and location of that pipe. So there's some of the pipes. I went underneath these couple here, and I found a set of about 6 of those 1.5 inches. They're just underneath that concrete to the left over here, and they were deep enough. They're about 2 feet deep, so we were able to go above them. Here's the poly pipe. It came in a roll, and I've got about 30 feet here. And I'm also upgrading the diameter of the pipe. It was 1.5 inches in there, but I just went to a 2-inch. Now here's the tool I was telling you about, and here's the transition fittings too that go steel, because you need steel 6 inches above top of concrete. You can't have the plastic going above the concrete, because if someone were to hit that with something and cut the plastic with a who knows what edge or a mower, you could have a real big problem. So you want steel above grade. So that's why they have that steel nipple there and that transition fitting there. That way everything's above. Now I got this tool I rented, and I noticed there was a lot of debris, old plastic that was melted onto these heat terminals. So I had to get it off because I want a nice clean joint. Now this tool here, something you put around the pipe, so when you're heating the pipe, your pipe stays round, because when it gets really hot it becomes real pliable. So this little clamp we're going to throw on there. Also this here tool, it actually scrapes about a 30-degree angle on the outside edge of the pipe, so that after you heat it, it slides into the next fitting very easily. So you can see the plastic trimming left behind on it. Now I use the same thing again. They have all the way down to a 1/2 inch up to I think 2.5 inch. This particular kit will do from 1/2 inch to 2.5 inch. Now what I'm going to do is I'm going to use my felt pen magic marker, permanent pen marker, and I'm going to decipher the depth of how deep my fitting is going to go. So that way after I heat this, I can look at the mark on the pipe, and I know that it's deep enough when I get to that permanent pen marker. Also with that marker, I can also orientate how the pipe will come up, so that it's coming up parallel out of the trench instead of on an angle or something like that, because I don't want to put a lot of pressure on the pipe twisting it to make it fit. I just want it to be, you know, in the right place with no stress on any of the joints. So I took the heater cover off. This baby's about 40,000 BTUs right here. Now here's the little reducer fitting. They had 1.5 inches to what is that, 3/4? Yeah, 1.5 inches to 3/4 reducer there. So I'm going to disassemble that, and then because I want to get this riser out of there, because it's kind of right where I want my new riser. You know, to be honest, it's in a perfect spot. So what I'm going to do is, like I said, I'm disassembled the top portion of it. I've removed the union, the valve, and whatever else is in my way. So now I can cut the pipe off below grade with a Sawzall. Now there's your valve for your gas. You want to make sure that's off, you know, before you do anything. Also, what I did by removing the fittings by hand, that allowed any gas that was in that line, even though the valve's off, there could be trapped gas in the line potentially. So what I did was unscrewed the fittings and made sure all the gas escaped before I started using a Sawzall. So that's another thing you want to consider doing too. Now, as you can see, I moved that pipe pretty easy because those fittings are all loose back there that I noticed after I removed that riser. The riser was kind of holding everything in place. Once that riser came out, that little drop down from the meter just started wiggling in the wind. You can see how loose it is there. So I'm going to go I'm going to turn the main gas off as well, and then I'm going to work all the way back behind this other valve, because I want to tighten up all these fittings just to make sure. The nice thing about the union is you can work either direction. When you have a union in place, then you can make it all come together. You can do it without a union if you get reverse threads on a coupling, but unions are nice if you ever have to work on it in the future. Now what I had to do here is find the right adapter to put on this heat plate, which was in the kit, and let's see what was there was something missing here that I had to manufacture. What was it? I think it was it was the Allen wrench. The Allen wrench was missing out of the kit, and that's what changes the adapters for the pipe on the heat plate. Luckily I had one on my truck. So you can see how I'm spinning all those fittings. I did at least 3 turns before I was happy with its tightness. Now I'm going to start over, working back down into the hole. So here's my pipe. I've dropped it down in the trench. I've taped off the ends and pushed it under and around pipes. And I've removed the tape at each end. Now I can cut my length. I've taped the tracer wire to the pipe so it's right next to it all the way through. So now the question is determining where I want to cut it. What I used there was the skill saw with a diamond blade in it to cut this pipe. I wasn't happy with the cut. It wasn't very straight. So what I ended up doing is recutting it with a hand saw that's designed for this plastic pipe. And then it came out real nice and straight and square. You got to get those ends straight and square so that way it maxes out in your fitting and you get full depth penetration. Now I have to hone out both ends of the end of the other pipe. Here's the 90-degree fitting we're going to use to come up out of the hole. See, we stick the pipe in to this heated element, and I believe it's heated at 500 degrees. Was that what it was? It was 500, huh? Yeah, we had it at 500 degrees, and there is a thermostat on the side of that you can read. You have to wait till it hits 500 before you start heating your pipe. I leave it in there for about 16 to 20 seconds, and then I know it's hot enough, and then you just push it together and hold it for about 30 seconds so it doesn't move. I also had the magic marker on there, so I knew I was in full depth. See the clamp I put on there? That holds it round. Even though it's super hot, it won't collapse on you when you push it together, in other words. Now on these unions here, when I took it apart, I oiled it up a little bit, the whole flange and where they come together, and cleaned where they actually seal. The little WD-40 on there, and wiped them down nice, and worked just like new. So here we are back in the hole. Now this whole system has to be pressure tested overnight for a 24-hour period. It has to hold 15 pounds, and they have to have. We have a pressure gauge. We're gonna put a pressure gauge on this other end here. We'll hit it. We'll pump it up with. You can pump it up with a hand pump. I happen to use the air compressor to pump this pipe up, and I brought it up to 15 pounds, and then I wrapped it up for the day. Came back the next morning, and it had dropped about a half a pound. Maybe not even quite a half a pound, but it did drop a little bit, and I believe that was due to the temperature change from daytime to nighttime. I think the air actually cools, so it condenses, so you have less volume in air, less pressure. So that's how that works. Now if you had dropped a pound or something, or 2 pounds, then you know you got a leak. But anyway, during the day, I put the pressure back to 15. I left it on there. If it holds basically for 10 minutes, 5 minutes, it's good to go. And it definitely did that. So the nice thing about having the epoxy fittings, epoxy coated steel fittings here, that are going to go partially below grade, I won't have to wrap those with the 10 mil poly tape, and I won't have to use a primer because it's already a done deal. Now you could use a standard black pipe through this whole thing if you wanted to, but then you've got to prime all the pipes, you've got to put the 10 mil on it, a lot more steps. And it's still, even after you do all that, it's still not as good as the poly. Now, as you can see here, I've hit it with the air compressor. I brought my gauge up. And now we're going to see how she holds. I'll come back in the morning and see what she looks like. Right now, it's looking really good. It's holding tight. And the thing about just air is, if it is leaking, you can't smell it leaking. But so you got to have the gauge on there. That gives you a good indication whether it's holding or not. You can always get the bubbles that kids like to blow, the little bubbler things, blow bubbles with. You can pour that over all your fittings, and if you get bubbles coming off your pipe, it's leaking at that point also. So here's the pressure right here. It's not quite 5 pounds, but it's got to hold that. According to this particular city I'm in, needs to hold 5 pounds for 10 minutes. It can't move. So that's a pretty easy test. Some cities will require you an overnight for 15 pounds. But here it was a little different, so it's kind of nice. So here we've got it all backfilled. We've already passed inspection, of course, otherwise I wouldn't have backfilled it. So you got to leave your trenches open for inspection, of course. So you get that first, and then you got to go ahead to backfill. Now we're gonna I do have one chip that we got on this whole project, next to the saw cut when we did the removal, but that was pretty good considering we're in these tight quarters here. Now what I'm doing here is I'm drilling 3/8 holes, and I'm driving 3/8 rebar, so they're very tight fitting. So I'm pounding them in with the 8-pound sledgehammer, and I'm going to run one bar on top of those the long ways. Now a lot of times when you open something up like this, it weakens everything around it, all the other concrete and everything, but when you dowel it back in like this, it's no problem at all. You're not weakening anything. Now here's some stone here that I've got to cut. I'm going to get this cut ahead of time because I'm going to wet set this with my pour back. Now these particular stones were just some extras that they had been using around the house for stepping stones, and some of them were buried that I was able to scavenge up. I removed them, cleaned them. Now I'm going to use them for this getting this stone band back into shape. So what I'll do is I'll just pour the concrete in here solid, and then I'll just scrape out a 1/2 inch of concrete in this particular band, and I'll just push them down into the wet concrete. And the concrete will actually push up through the joints, and that'll also be my grout. So here we are. We're on this shady side of the house. And the thing about that is the concrete's not going to dry when you're on this particular side of the house. And for a job this small, you don't want to be sitting on it for a long time, just for a small piece. So what I did was I mixed my own concrete, and what I did here is I used half of the quick drying Quickcrete high performance concrete mix, which on the bag says you have about 20 minutes to work with it, and that's not quite enough time. So I went half and half of the regular set concrete to half of the fast setting concrete, and it was all about 4,500 5,500 psi stuff. So it went off really nice. It was very creamy, and I think I was wrapped up and poured out in about 2.5 hours, and this stuff went off. Now we're going to have to do a little salt finish too in here, make it match everything else. We have the area drain there, and that was the existing. We didn't damage any of the underground pipe, so it was really easy to put it all back together. So here's the stone I just sunk in. Now what I'm doing is I'm pulling some cream off the top of the concrete and slam it into the joints. And then what I'll do is let that get hard and just give it a light sponge down, enough to clean the stone, but not enough to expose the aggregate in those grout joints. A very delicate process. Well, what we've done is we've continued all the joint lines that were in the existing right through the bands. So when this cures out about the same color as the rest, it won't be as noticeable. And then of course we're not going to run an edger along the saw cut joints. We want to keep it tight and clean as possible. We try to hide the saw cut as much as possible, so we'll trowel it in tight and broom it in. And then what we'll do is we'll just tap some salt in to give it the salt look. The brooming's important because with salt alone it still is pretty slippery. So the broom gives it that non-slip texture. And especially this side of the house where things are going to stay wet longer. Smooth concrete when wet is slippery. Bottom line. Anyway, thank you for watching the videos. If you have any questions or comments, don't hesitate to call me, contact me. If you like these kind of videos, subscribe. If you want to see the latest and greatest as they roll out, hit the little bell button next to the subscribe. You'll get a notice when I post. Thank you for watching. Have a good day. Bye.